It's a branch of physics that deals with the generation or say production, propagation, and properties of light. Then, so this optics we can classify into two parts. One is ray optics. It's also called as geometrical optics. Another is wave optics or physical optics. So what do you mean by ray optics? Is we have to justify this. So why you are calling that particular called as ray or geometrical optics? Why do this word geometry is brought very specifically? So these things is what I'm going to try to justify here. So let me begin with so let there be a source of light. So I'll do one thing. I'll take some a wooden box. I'll take it. Okay, there's a wooden box. At the center of the wooden box, let me keep a source of light. There's a lamp. Then I'm going to make a small holes. In all sides, let me make a small holes. I can only, I think I can show this one. So now if I switch on the lamp, it's a wooden box. So what it is basically, and wooden box. Okay, when I switch on the lamp, what do we notice here? So here the wave, what will happen? The light energy, let me represent with an yellow color one. So through this, so what we notice is like, I'll see only through few holes I'll show it. Let's say it'll be, I think most of you are able to imagine what I wanted to present through the picture. Now what is this yellow color one, arrows? They will represent the light energy which is diverging from through that holes here. So what is the point of divergence? The lamp, the source. So what is this lamp? Lamp is a, so what is the lamp shall we call? Lamp is a source of light. Where do this wooden box is kept? Wooden box lying in a pitch dark room. There's a complete dark room. So when you switch on that lamp, so what you notice? You're going to notice some light energy coming through that hole, a divergent, like some sort of like a ray. What you can see, that there's a very general. I think anyone uh, can do notice such things. Not something very high scientific one. So in a pitch dark room, so you place an wooden box. In that wooden box, you arrange a lamp. Switch on that lamp. I think nowadays lamp very easy. Just to take mobile, you'll have a LED in that one. Switch on that lamp. Through that hole, so open, the light energy will flow radially outward. So what is this? What we should call light energy flowing radially outward, or mm, or light energy diverging from the source. Okay, what is the point of divergence? The lamp itself, the electric lamp itself is the point of divergence. From there, it is coming here now. Now, these holes, I'll decrease the size of area of cross section of these holes. Definitely, what will happen to this? The light, the thickness of this beam, it will also decrease. So I'll make it, the size of hole is so small that it is almost, let me assume this like a one line. There's only a theoretical assumption. There's only a theoretical assumption. Now, definitely what I can say, the light energy is propagating in this direction. So what do these arrows will indicate now? Light energy flowing radially outward, or these arrows indicate, yellow color arrows indicate propagation of the light energy. And how do it is? It is just diverging from the point source. So shall we call this as some sort of like a ray? So shall I call, instead of this one, light energy flowing radially outward, I'll call them as light rays. This yellow color lines are called as the light rays. So we'll, yellow color lines are called as light rays. Getting the idea? So now, so what we can call like, it means now I'm saying the light energy propagates. So what do you mean by light energy? So like it's a light is a form of energy. Then light energy flows radially outward, or light energy diverging from the source, or nothing but like the wave is moving away from the lamp. It is. So if you come for wave optics, what you are going to say like so in the wave optic, the same approximation we are going to do like this. So here I'm going to bring a, okay, these are called as blue color. They're not circle, concentric circles. So what is this one? This blue color, like a spherical wavefronts, they're called as, or shells, you can say like a spherical wavefronts. And this will indicate the direction of, this arrow will indicate, yellow color arrows indicate direction of wave propagation. How the direction of wave propagation will be always perpendicular to the wavefront. So what are these wavefronts? Wavefronts, it's a plane in which all points will have same phase. So further we'll define what do you mean by wavefront. It's a plane in which all particles will have same phase. So like this, what happen, we'll define it. So if you are here, what happened? I'm discussing the light energy in the form of a wave. Here, the light energy in the form of like a ray of light. We are bringing some geometry into the picture. Okay, light ray. So what is a light ray? It's like a, how I'm showing that the light energy flowing now, I'm showing it in the form of like a geometrical line. So what is a light ray now? Light ray, shall I call it, it's a geometrical concept. Say light energy is diverging radially outward from the lamp. That light energy, what happened? I am showing by in these arrows, radially outward arrows. So what is this arrow? It is some sort of, shall I call that as a ray? So what is the light ray now? The light ray is nothing but a geometrical concept. What do this arrow will indicate? The direction of propagation of light. So therefore, here what we are doing is like, what is the advantage of this geometrical optics or ray optics? Is like it's very easy to study the properties of light. Doing this one. So what do you mean by that? The direction of this arrow will indicate the direction of propagation of energy. I think this is a very, very important condition is what I'm bringing. So what is this one? The direction of arrow indicates the direction of propagation of light energy. I think this is something very, very the fundamental one. So therefore, so just by drawing a one line and putting on arrow, so indirectly what you are seeing is the light energy propagates in this particular direction. So now I'll switch on the lamp. If I ask you how the light energy flows, okay, just draw some arrows. So what is this arrow? This is a geometrical line. So here what happened? The light ray is what now is a geometrical concept is what I'm going to introduce here. What is the advantage of this? This will be much easier because everyone knows how to deal with a straight line. How to deal with a straight line? We know enough geometry. That one. So even the light gets reflected, changes direction as we know how to draw a curves, how to draw a straight line. So it'll be very easy for us to study now the property of light with this particular idealization. Go here, but it's having its own limitation. So what is this? This is like a, so what we can conclude here, the ray optics is an approximate method for solving numericals. It's approximated, no, not exact. We can just say, okay, it's an approximate method for solving the numericals here. And moreover, the light will propagate in a straight line. These are some properties are there. Light will get, light rays can intersect each other. Light rays can get reflected, refracted. So all fourth one, light rays propagate in straight line. So with what speed they'll propagate? V is equal to in a medium. So in air, what is the speed of light? Speed of light in vacuum is in any medium where mu is called as refractive index of the medium. Later on we'll explore. Just the beginning part. No, I was supposed to give all this approximation. Okay, now what is the final conclusion? We can study the behavior of light, or we can study the properties of light by two methods. One, by treating the flow of light energy, by representing the flow of light energy by a ray or by a straight line, and the direction of arrow and the direction of propagation is given by the direction of arrow. So therefore, this yellow color lines here, of course, I'm going to call that as a light ray. This is the one method. What is another method? Treating the light energy as a wave. And the source or pin is going to give a the source is going to emit the light waves, and how the light waves will propagate direction. The direction of propagation of light waves will be perpendicular to the wavelength. So this is again the lamp. So there's a good example is you drop a stone in a calm lake, you see the ripples, no? So nothing but that what happened. They're like a surface wave, they're called. Similarly here, the lamp will be continuously will be emitting the light energy. That propagation of light energy we can represent by a wavelength, and perpendicular to, and how the direction of propagation will be normal to the wavelength. So if you know, and the wavefronts can be plane, spherical, cylindrical, it all depends upon the physical conditions. Now, when to use ray optics, when to use geometrical optics, it all depends upon the situation. It all depends upon the physical conditions, where like a ray optics is valid, okay, go for ray optics valid. Where ray optics is invalid, then come to the wave optics. So either of approaches what happen, we are going to follow that one. So it all depends on the physical situation where the ray optics will be valid, and the wave optics what happen in some situations may not be applicable, like photoelectric effect where you cannot bring the wave nature of light. The ray optics is an approximated method. Ray optics is an approximated method which will easily help us to study the light energy, the properties of light. So we'll focus more on in the initial part of our ray optics is what finally primary will discuss here. After the end of this chapter, then we'll go for the wave optics.